There's always a danger of fire, particularly when people are careless.
Door, please. Yeah. Put your upstairs, mate. What's the water? Come in. Work upstairs.
The fire brigade use water for most fires in houses, but different methods can be better for different kinds of fires.
Hold the horn there.
Extinguishers filled with carbon dioxide are useful indoors. Why do you think they aren't very effective outside? For a wood fire, the best thing is water.
Right, work all round it, in between the wood.
For a fire in a chip pan, use a damp tea towel.
Drape it over. Out straight away. Remember, once it's out, don't pick the pan up and take it away. Let the pan cool.
For an oil fire, what you must never use is water.
Why you should never use water on an oil fire. Flared up like that. Not only flared up, but it can spill over the side.
The best way to put out an oil fire is with an extinguisher of dry powder.
That's it, as quick as that.
To find out about fire, you need a scientific eye. Why do things burn? Before any flame will burn, it needs 3 things. What are they? The 3 things needed for a fire are often represented as a fire triangle. A flame is a chemical reaction. It needs fuel, oxygen and heat. Fuel to burn, oxygen to react with it, and heat to start the reaction and to keep it going. What will happen if you cut off the fuel? What if you cut off the oxygen? Why doesn't the paper catch fire? There's water inside it. The water takes the heat away, and without the heat, the paper won't burn. Things we can burn safely to get energy we call fuels. Candle wax and camping gas and wood are all fuels. How many useful fuels can you think of? There are 6 different fuels being used in this village. Look at what they're being used for. Are there any other fuels that could do the job as well? How do fuels burn? There's a clue here. Some fuels are liquids. But what actually burns is not the liquid, but the gas or vapour that comes off it. Here are 3 fuels: methylated spirits or meths, petrol, and paraffin. Paraffin is a useful fuel, but it doesn't catch fire easily. Let's find out why. Look carefully at this petrol flame. Notice where it comes from. Does the petrol burn from the bottom of the liquid or all the way through? No, the flame starts well above the surface. Here's some warm fuel in a beaker. None is tipping out, but the shadow shows that something is pouring from the spout. There's fuel vapour above the surface. Vapour is what's pouring out. Could it be the vapour that burns? Warm fuel light the vapour above the gauze. So it is the vapour that burns. The flame never gets near the liquid at all. Some fuels give off vapour more easily than others. So now can you think why the paraffin on the right did not catch fire? Let's see how easily different fuels catch fire or ignite. Gases ignite very easily. It only takes a spark or a match. This welding torch uses acetylene gas. The gas burns easily because the torch mixes it with oxygen. Watch what happens in slow motion when a cylinder of fuel explodes near a flame. First, vapour mixes with air, then it ignites. It's because gas ignites so easily that gas explosions are so dangerous. Gas explosions can bring whole buildings to the ground. So, what should you do if you smell a gas leak? Space rockets use gas fuels. And they have to carry both the fuel and the oxygen with them. There's no oxygen in space. If you want a solid to burn as fiercely as this, you have to pack oxygen in with it. The sparks are little bits of burning iron. They burn because there's oxygen trapped chemically in the sparkler. All fireworks have oxygen trapped chemically in them. That's why the little bits of solid burn so brightly. This slow-burning fuse has chemically trapped oxygen in it. What do you think will happen when the flame gets down to the water level? What other solids will burn easily? Not fiberglass, that's why it's used for insulation. Nor pots made from clay. Lumps of coal don't catch easily either. Even wood won't light in big pieces. But smaller pieces of the same wood will ignite. And shavings catch fire easily. Why does this happen? Remember, lumps of coal won't ignite, but coal dust will burn easily if you blow it into a flame. So will aluminium powder. Solids will burn if they're in small enough pieces and if they're thoroughly mixed with oxygen. Powders like flour and icing sugar are just the same. Corn flour won't burn in a heap. But see what happens when it's thoroughly mixed with oxygen. Flour and even custard powder can make devastating explosions. This factory in Banbury was blown apart by one. That's why scientists investigate dust explosions to try and prevent them. Someone once blew up a piano as part of an act. That was 9 ounces of explosive powder, but for extra drama they put in some flour. Look what happened with only half the explosive plus flour. What about the colour of flames? A meth flame is blue. A petrol flame is yellow. Can you guess which might be the hotter and the more dangerous? A Bunsen flame is yellow when the air hole is shut, but it changes if you open the air hole. Can you explain why the flame goes blue? Candle flames are yellow and very dirty. Might this make any difference to how hot and how dangerous they are? On the 14th of February 1981, at this disco in Dublin, there was a terrible fire in the early hours of the morning. 50 teenagers died, and afterwards the whole building was a wreck. What the scientists wanted to find out was how the fire had spread so quickly. First, they looked at the materials in the disco. How easily would they ignite? They found that the seats could not be ignited with a lighted match, unless the seat cover was already damaged. So the fire couldn't have spread along the seats. But they wondered about the carpet tiles that had been on the walls. They built a replica of part of the disco inside a huge building and started a little fire on a seat at the back. Sure enough, the fire burned quickly up the wall to the ceiling, and then it spread, not over the seats, but across the ceiling. Fierce heat from the yellow flames above quickly set fire to more rows of seats. Watch the ashtray on the table on the left. Within 90 seconds, the room was a raging inferno. What should you do if you spot even a little fire?